Atoms. Size. The atomic size depends on the number of electron orbits in the atom. The greater the number of orbits, the larger the size. Mass. The mass of an atom is concentrated in its nucleus, and it is due to the protons p and neutrons n in it. Valency. The capacity of an element to combine is called its valency. Measurement of matter. Learning objectives. At the end of this chapter, you will be able to learn about laws of chemical combination, law of conservation of matter, law of constant proportion, chemical symbols of elements, molecular mass and the concept of mole, Avogadro's number. Laws of chemical combination. The composition of a substance changes during a chemical change. The fundamental experiment in this regard was performed by scientists in the 18th and 19th century. The scientists Dalton, Thomson, and Rutherford studied the structure of substances and the atom, and thus discovered the laws of chemical combination. Law of conservation of matter. In 1785, the French scientist Antoine Lavoisier inferred from his research that there is no rise or drop in the weight of the matter during a chemical reaction. In a chemical reaction, the total weight of the reactants is same as the total weight of the products formed during the chemical reactions, and this is called the law of conservation of matter. Law of constant proportion. In 1794, the French scientist J. L. Proust stated that law of constant proportions as the proportion by weight of the constituent elements in the various samples of a compound is fixed. 1. The proportion by weight of hydrogen and oxygen in water is 1:8. This means that 9 gram water is formed by chemical combination of 1 gram hydrogen and 8 gram oxygen. Example number 2. The proportion of weight of carbon and oxygen in carbon dioxide is 3:8. That is, in 44 gram carbon dioxide, there is 12 gram of carbon and 32 gram of oxygen, so that the proportion by weight of carbon and oxygen is 3:8. Atom, size, mass, and valency. An atom consists the nucleus and electrons. The nucleus consists neutrons and protons. The electrons are negatively charged elementary particles, while the elementary particles that make up the nucleus are positively charged protons and electrically neutral neutrons. The size of an atom is determined by its radius. The atomic radius of an isolated atom is the distance between the nucleus of an atom and its outermost orbit. The atomic radius is expressed in nanometers. The atomic size depends on the number of electron orbits in the atom. The greater the number of orbits, the larger the size. For example, an atom of K is bigger than an atom of Na. If two atoms have the same outermost orbit, then the atom having the larger number of electrons in the outermost orbit is smaller than the one having fewer electrons in the same outermost orbit. For example, an atom of Mg is smaller than an atom of Na. The mass of an atom. The mass of an atom is concentrated in its nucleus, and it is due to the protons p and neutrons n in it. The number p plus n in the atomic nucleus is called the atomic mass number. Protons and neutrons are together called nucleons. It was not possible for scientists of the 19th century to measure atomic mass accurately. Therefore, the concept of relative mass of an atom was put forth. The hydrogen atom, being the lightest, was initially chosen as the reference atom. The relative mass of a hydrogen atom, which has only one proton in its nucleus, was accepted as 1. Therefore, the magnitude of the relative atomic masses of various atoms became equal to their atomic mass number, p plus n. Let us see how to express the relative mass of a nitrogen atom, having accepted the relative atomic mass of hydrogen as 1. The mass of one nitrogen atom is 14 times that of hydrogen atom. Therefore, the relative mass of a nitrogen atom is 14. This is how the relative atomic masses of various elements were determined. In 1961, the carbon atom was selected as the reference atom. In this scale, the relative mass a carbon atom was accepted as 12. The relative atomic mass of one hydrogen atom compared to the carbon atom becomes 12x 1 by 12, that is 1. The mass of one proton and of one neutron on the scale of relative atomic masses is approximately 1. Today we have highly accurate methods of measuring the mass of an atom directly. Hence, instead of relative mass, unified mass has now been accepted as the unit of atomic mass. It is called Dalton. Its symbol is U. 1 U is equal to 1.66053904, 10-27 kilogram. Dalton used certain signs to represent elements. Today we use the symbols determined by IUPAC, International Union of Pure and Applied Chemistry. The current method of choosing chemical symbols is based on the method invented by Berzelius. According to this method, the symbol of an element is either the first letter or the first and second or another specific letter in its name. Of the two letters, the first is a capital letter and the second is small. Molecules of elements and compounds. Atoms of some elements such as helium, neon, have independent existence. It means that these elements are in a monoatomic molecular state. Sometimes two or more atoms of an element combine to form molecules of that element. Such elements are in a polyatomic molecular state. For example, the elements oxygen, nitrogen are in a diatomic molecular state as O2, N2 respectively. When atoms of different elements combine with each other, the molecules of compounds are formed. In other words, compounds are formed by chemical attraction between different elements. Molecular mass and the concept of mole. Molecular mass. The molecular mass of a substance is the sum of the atomic masses of all the atoms in a single molecule of that substance. Like atomic mass, molecular mass is also expressed in the unit Dalton U. When elements and compounds take part in chemical reactions, it is their atoms and molecules that react with each other, and therefore it is necessary to know the numbers of their atoms and molecules. However, while carrying out a chemical reaction, it is convenient to measure out quantities that can be handled instead of counting the number of atoms and molecules. The concept of mole is useful for this purpose. A mole is that quantity of a substance whose mass in grams is equal to magnitude to the molecular mass of that substance in daltons. Thus, the molecular mass of oxygen is 32 dalton, and therefore 32 gram oxygen is 1 mole of oxygen. The molecular mass of water is 18 dalton, therefore 18 gram of water make 1 mole of water. 1 mole of a compound is the mass of that substance in grams, equal to magnitude to its molecular mass, that is, SI unit of mole. Number of moles of a substance is N is equal to mass of substance in grams, molecular mass of substance. Avogadro's number. The number of molecules in 1 mole of any substance is constant. The Italian scientist Avogadro did pioneering work in this context. Therefore, this number is called Avogadro's number and is denoted by the symbol Na. 1 dozen bananas are 12 bananas. 144 notebooks make 1 gross of notebooks. 1 mole water is equal to 6.022 multiplied by 10 raised to the power 23 molecules. 1 mole common salt, 6.022 multiplied by 10 raised to the power 23 molecules. A mole of any substance stands for 6.022 multiplied by 10 raised to the power 23 molecules. For example, a mole of water, that is 18 gram of water, contains 6.022 multiplied by 10 raised to the power 23 molecules of water. To calculate molecules of CO2, how many molecules are there in 66 gram of CO2? Method: molecular mass of CO2 is 44. Mass of CO2 in grams is equal to 66. Molecular mass of CO2, 44. N is equal to 1.5 mole. 1 mole of CO2 contains 6.022 multiplied by 10 raised to the power 23 molecules. 1.5 molecule CO2 contains 1.5 multiplied by 6.022 multiplied by 10 raised to the power 23 molecules is equal to 9.033 multiplied by 10 raised to the power 23 molecules. Valency. The capacity of an element to combine is called its valency. The valency of an element is the number of chemical bonds formed by one atom of that element with other atoms. A sodium atom gives away one E, and a cation of sodium is formed. Hence, the valency of sodium is 1. A chlorine atom takes up one E and forms an anion of chlorine, chloride, and thus the valency of chlorine is 1. Due to the attraction between the unit but opposite charges on the two ions, one chemical bond is formed between Na plus and Cl minus. Variable valency. Under different conditions, the atoms of some elements give away or take up different numbers of electrons. In such cases, those elements exhibit more than one valency. This property of elements is called variable valency. Iron, Fe, exhibits the variable valencies 2 and 3. Therefore, iron forms two compounds with chlorine FeCl2 and FeCl3. Radicals. Compounds with ionic bonds have two constituents. These are a cation, positively charged ion, and anion, negatively charged ion. They take part independently in chemical reactions and are therefore called radicals. Different bases such as NaOH, KOH are formed when various cationic radicals are paired with anionic radical hydroxide. Hence, the cationic radicals are also called basic radicals. On the other hand, different acids such as HCl, HBr are formed when various anionic radicals are paired with the cationic radical H. Therefore, the anionic radicals are called acidic radicals. Chemical formulae of compounds. Recapitulation. The characteristics of a compound formed by ionic bonds is that its molecule has two parts. These are a cation and an anion, that is, a basic radical and an acidic radical. These two parts are oppositely charged. The force of attraction between them constitutes the ionic bond. The name of an ionic compound has two words. The first word is the name of the cation, and the second is the name of the anion. The steps for writing a chemical formula are shown. Step 1. To write the symbol of the radicals, basic radical on the left, NaSO4. Step 2. To write the valency below the respective radical, NaSO4, 1, 2. Step 3. To cross multiply as shown by arrows the number of radicals, NaSO4, 1, 2. Step 4. To write down the chemical formula of the compound Na2SO4. Summary. You have learned that the scientists Dalton, Thomson and Rutherford studied the structure of substances and the atom, and thus discovered the laws of chemical combination. In a chemical reaction, the total weight of the reactants is same as the total weight of the products formed due to the chemical reactions, and this is called the law of conservation of matter. In 1794, the French scientist J. L. Proust stated that law of constant proportions as the proportion by weight of the constituent elements in various samples of a compound is fixed. The molecular mass of a substance is the sum of atomic masses of all the atoms in a single molecule of that substance. A mole is that quantity of a substance whose mass in grams is equal to magnitude to the molecular mass of that substance in Daltons. A mole of any substance stands for 6.022 multiplied by 1023 molecules. The valency of an electron is the number of chemical bonds formed by one atom of that element with other atoms. The force of attraction between them constitutes the ionic bond.